now we are going to cover 4.2 Determinant of Matrices. Okay, so we have two learning outcomes to accomplish. So first we are going to find the minus and cofactors of a matrix, and then second one we are going to find the determinant of a matrix. Okay, so now let's see the definition of cofactors and minus. Okay, so as we can see here, okay, minor is represented by the letter M, while cofactor is represented by small letter C. So minor, so minor element is equal to Mij, where I is represented by the row and J is represented by the column. Okay, so minor element Mij is the determinant of the matrix remains after deleting the ith row and jth column. Okay, whereby cofactor, okay, what is cofactor? So cofactor is represented by, so this is cofactor elements. Okay, cofactor is represented by Cij, where Cij is equal to -1 to the power of I plus j times Mij, where M is basically the minor. Okay, so now in order to find minor of a matrix, so let's see an example here. So we have this example. Okay, so matrix A is given by this. So okay, we are going to solve the second question first, and then later on we will continue with the first Roman. Okay, so the second Roman is stated there, we need to find the minor of A. Okay, so again, what is minor? So minor is Mij, which is the determinant of the matrix remains after we delete the ith row and jth column. Okay, so now let's see. In order to find M11, okay, so where 1 here, the first one is represented by the row and the second one is represented by the column. Okay, so again, okay, minor is the determinant of the matrix remains after we delete the respective row and column, right? So here we are going to delete the first row and first column. Okay, so we're going to take this, we're going to cover the first row and first column. Okay, now we can see the elements remain. Okay, so the Mij M11 is basically the determinant of 1, -1, -3 and -3. Okay, while M12 is basically the determinant of the matrix remain, okay, when we delete or when we close the first row and second column. So what we're going to do, okay, we're going to move this, okay, and we close the second column. So the elements that we can see here is 5, -1, 2, -3. Okay, and then what is Mi3? So Mi3 is the minor, okay, for the first row and third column. So again, we're going to close the first row and third column here. So we can see that the elements remain are 5, 1, 2, -3. Okay, so please bear in mind that, okay, the minor elements here are all the determinants. So we are going to find the determinant. Okay, so if you can see here, determinant of 2 by 2 matrix is the subtraction of the product of the major diagonal elements with this element. So we have A multiply D minus with B multiply C. So we are going to find the value. So we have 1 times -3 minus with -3 times -1. So we have actually -3 minus 3. So we have -6. Okay, then here to find the determinant, it's 5 times -3 minus with 2 times -1. So we have -15 plus 2. So we have -13. Okay, and then for M13, so we have 5 times -3 minus with 2 times 1. So we will have -15 minus 2, which is -17. So these are the minor elements for the first row. Okay, so we have M11, M12 and M13. Then what about M21? Okay, M22 and M23. So again, we're going to do the same thing. So we're going to close the respective column, row and column, in order to find the elements remain. Okay, so now let's move here. Okay, so we are going to close the second row. Okay, then we are going to close now the first column. So now let's see what are the elements remain. Okay, so we do have 1, 1, -3, -3. Okay, then also we move this. Okay, we close the second column. So we can say the elements remain 0, 1, 2, -3. And here we close the third column. So we will see 0, 1, 2, -3. Okay, then we find the values by finding the determinants. So we have -3 minus -3. So we will get 0 here. So we will have 0 times -3 minus 2 times 1, which is 2. So it's -2. And then we have 0 minus 2. So we have -2 as well. Okay, then, okay, we are not done yet because we need to find for the third row. So we are going to find M31, M32 and M33. Okay, so let's find out what are the elements remain. So first we close the first column. So we will see the elements 1, 1, 1, -1. Okay, and then we close the second column. So we can see the elements 0, 1, 5, -1, and lastly we close the third row and third column. So we will see the elements remain 0, 1, 5, 1. Okay, then the rest is just about, okay, finding the determinants. So we have -1 minus 1, so we will have -2. And then here we have 0 minus 5 times 1, which is 5, so we have -5 here. And then we have 0 minus 5, also -5. So these are all the minor elements. Okay, now since the question says find the minor of A, means we are going to finalize in matrix form. So how to finalize in matrix form? So we are going to finalize the answer. Minor of A, okay, so it's basically the matrix of consisting the elements. So we get this first element, -6, followed by -13, -17, and then 0, -2, -2, -2 here, -5 and -5. So this is basically the minor matrix of A. So after we have got the minor of A, and then how to solve this? Okay, how to find the adjoint of A? So adjoint of A, okay, we can write down as adjoint ADJ. Okay, so adjoint of A is the cofactor matrix transpose. Okay, so how to find cofactor matrix? Okay, so we have the formula. So cofactor, so just now we have cofactor element. Okay, so cofactor element is represented by small letter C. So Cij, so the formula of Cij is equal to -1 to the power of I plus j times Mij, whereby M is the minor element. Okay, so how to find cofactor matrix? So okay, we need to find the cofactor element first. So what? Okay, is C11. So C11, if we substitute into this formula, so we will have -1 to the power of 1 plus 1 times M11. Okay, so we will have negative 1 power 2, so we will have positive of M11. Okay, then if we write down C12, so the formula is negative 1 to the power of 1 plus 2 times M12. Okay, so negative 1 to the power of 3 is negative M12. And then we have C13. So C13 is cofactor element in the first row, third column. So we have negative 1 to the power of 1 plus 3 times M13. So we will have negative 1 to the power of 4, which is positive M13. Okay, then we use the same formula also to find the C21. So negative 1 to the power of 2 plus 1 times M21. So we will have negative 1 power 3, which is negative of M21. And then we have C22, which is negative 1 to the power of 2 plus 2 times M22. And we know that negative 1 power 4 is positive. So we have positive of M22. And then we have C23. So negative 1 to the power of 2 plus 3 times M23. So we will have negative 1 to the power of 5, which is negative 1 times M23. And then lastly, we find the cofactor elements for the third row. So we have C31. So we have negative 1 to the power of 3 plus 1 times M31. So we have negative 1 to the power of 4, which is positive M31. And then we find C32. So we substitute into the formula negative 1 to the power of 3 plus 2 times M32. And then we will get negative of M32. And then we have C33. Okay, so the last cofactor element. So negative 1 to the power of 3 plus 3 times M33. So we will have negative 1 to the power of 6, which is positive of M33. Okay, so if you notice that the signs here are all alternating. So it begins with positive, followed by negative, and then positive, negative, positive, negative, positive, negative, and lastly positive. Okay, so basically in order to find cofactor, so cofactor matrix, okay, is basically the all plus minus plus minus plus minus plus minus plus of the minor matrix. So we move down the minor just now, so the minor matrix here. Okay, so we just bring down all the elements here. Okay, so we will have positive of negative 6, and then negative 13, and then negative 17, then 0, negative 2, negative 2, negative 2 here, negative 5, and negative 5. Okay, then we simplify everything here. So you will have negative 6, 13, negative 17, 0, negative 2, positive 2, negative 2, positive 5, and lastly negative 5. So this is cofactor matrix of A. And then, okay, coming back to the third Roman question, okay, the question asks us to find the adjoint. So adjoint matrix, okay, is basically the cofactor transpose. So what we're going to do, we're going to copy down each and every element here. Negative 6, 0, negative 2, 13, negative 2, 5, negative 17, 2, negative 5, and we're going to transpose this matrix. Okay, so how to transpose a matrix again? Okay, we change the row to be column, or we can change the column to be the row. So now let's take the first row here. Okay, so we change it to be the first column. So negative 6, 13, negative 17, and then we take the second row to be the second column, 0, negative 2, and 2, and we take the third row here to become the third column, which is negative 2, 5, and negative 5. So this is the adjoint matrix of A. Okay, so now how to accomplish the second learning outcome? Okay, how to find determinant. So we discussed just now how to find determinant of 2 by 2 matrix. Alright, now so how to find determinant of 3 by 3 matrix. Okay, so we do have this formula here. Okay, so I'm going to write down the formula. So determinant of a matrix is the sum of Aij and Cij. Okay, so whereby Aij is the element, okay, in the respective row and column, while Cij is the cofactor element. Okay, so Aij is the element in the matrix, okay, of the respective matrix, and Cij is the cofactor element. Okay, so in order to find determinant, we may expand any row or any column. Okay, so we may expand any row or any column. Okay, so the tip is we may find any row or any column with element 0, so that okay, it will make the working solution easier. Okay, so now let us see this matrix A. Okay, so in order to find the determinant of A, so we may expand. Okay, so we are going to expand the first row here. Okay, so I'm going to use the formula. Okay, so determinant of A is the sum of Aij multiplied by Cij. Okay, now how to find the determinant? So we are going to expand the first row. So we write down here by expanding first row. So we will have A11 C11 plus A12 C12 plus A13 times C13, and we discussed just now cofactor element. So again we write down C1 Cij is equal to -1 to the power of I plus j times M1 ij. Okay, so basically cofactor element is the plus minus plus of the minor, right? So we will have okay, positive of A11 M11 minus A12 M12 plus A13 M13. Okay, then what is A11? So A11 is here, so it's 0 times the minor. So now let's close the first row and first column of the matrix. So we will see that the elements remain on 1, -1, -3 and -3, and then minus with, okay, so A12, so A12 is here, its element located in the first row and second column. So we write down 1. Okay, then how to find the minor? So basically we will close the first row and second column. So we will get the elements remain 5, -1, 2 and -3, plus with A13. So this is A13, element located in the first row and third column. Okay, then how to find M13? Okay, so we close the first row and third column. So we can see that the elements remain 5, 1, 2, -3. Okay, and how to find the determinant? So first we just find the determinants of this. So it's 1 times -3, so -3 minus 3, so -1 times -15 plus 2 plus with 1 times -15 minus 2. So we will have 0 minus with -13 plus with -17. Okay, so we will have 13 minus 17, which is -4. Okay, alternatively, we may also find the determinant by expanding first column. Okay, so now let's see how to find the determinant. So we substitute into the formula, so we will have A11 C11 plus A21 C21, okay, plus A31 C31. Okay, so because we are expanding first column, so everything here coming from the first column. Okay, so and we recall the Cij is equal to -1 to the power of I plus j mij. So we will get the C11 equals to positive of M11 minus with A21 M21 plus A31 M31. Okay, so now let's get the element. So A11 is 0. So M11 is the determinant of the matrix remain. After we close the first row and first column, so we will have 1, -1, -3, -3 minus with A21. So A21 is the element located in the second row first column. So we have 5 here. And if we close the second row and first column, so we can see the elements remain are 1, 1, -3, -3, and then plus with, okay, the element in the third row first column is 2, and then if we close the respective row and column, we will get 1, 1, 1, -1. Okay, then the rest is all about finding the values. So we have 0 here, -5, so it's -3 minus -3 plus 2, -1 minus 1. So how to find the value? So we just simplify everything. So we have -5 times 0 plus with 2 times -2. So here we have 0 plus -4, so we have -4 to be the answer. Okay, so we can see here, even though we expand a different row and different column, so by right we should be able to get the same answer for both. Okay, and you may try also to expand the second row or third row, or in fact the second column, third column, so you'll be able to find the same value of determinant for this particular matrix of A.